For problem number 1, we decided that to set hiker 1 is equal to distance over time. So that was their basic rate of how fast they were walking, because they were walking at a constant speed. And then for hiker 2, they had also as a constant speed, but they arrived 2.5 hours after this the first hiker. So that's why we have their rate is d divided by t plus 2.5. So they had the extra 2.5 hours added to their time. So that's how we got their rates. And then we wanted to find the distance at what point did they meet up at. So we have the 3 hours when they met. So that's why you do the 3 times the rate of the first hiker plus the 3 times the rate of the second hiker, which is equal to d. So once you come to that equation, then you can factor out a 3 and then divide the 3 onto the other side. So that's why you get d divided by 3. So once you realize that you're left with this equation, you see that there's d, a d, a d, which you can divide out the d. And so then it's just like 1 plus t plus 1 over t plus 2.5 is equal to 1/3. And so basically you're just going to manipulate these equations algebraically, so multiplying to get a common denominator. And then once you get the common denominator, you can multiply the denominator on the other side to set them equal to each other. Then you bring the 6t and the 7.5 over to set it equal to 0, which then you could use the quadratic equation. I just decided to multiply the entire thing by 2 so that I could factor it, because I didn't want to deal with the 0.5s, the decimals. So I have 2t squared minus 7t minus 15 is equal to 0. And then you can factor that to be 2t plus 3 times t minus 5. So you get t is equal to either 5 or negative 3 halves. And because t is representing time, you can't have a negative time. So then you're left with t is equal to 5. So when you go back and plug that into the equation, then you see that 5 plus 2.5 gives you 7.5 hours. So they arrived at Amityville at 8:30 p.m.